Good afternoon, everyone. It gives me great pleasure to welcome you to the Big Data Mauritius Hackathon. My name is Regin Ramphel, and I am a data scientist at a company called OrderIn. Before we start the talk, which is around data science in industry, I would like to give a little bit of background on myself so that you understand how I became a data scientist. So I did my undergraduate in physics at the University of Mauritius. And then after that, I got a bursary to do astronomy and astrophysics at the University of Cape Town. I did my postgraduate at UCT, and then I graduated with my PhD in 2018. And throughout the years of my PhD, data science and machine learning especially became very popular and was the whole hype around all that industry in the news, in books, and everywhere. So because of that, the interest that I had for data science grew, and myself, I started being part of workshops and help organize workshops around the topic. And then after I graduated in 2018, I decided to formalize my education inside that whole field. So I did a few online courses on data science, deep learning, machine learning, and then I was lucky enough to be accepted at a school, the Data Science Intensive School in Cape Town. I participated in that school for 2 months, and it was around building data science solution for industry mostly. After that, I did a few internship jobs, and then I moved to my first full-time job at a business consulting company, which was centered around data science itself. And then at the end of last year, I moved to a new company called OrderIn, which does delivery, food delivery more specifically. And data science is also central to the business where I am currently. So that's my background, and now let's dive into the talk. So data science is being used, or AI as people are speaking about it, being used in a variety of industry currently. For example, data science is being used in recommendation engine like Amazon or Netflix, where customers are being recommended products or movies based on their past history on the platform. We also have algorithm which does spam filtering, because most of our emails are in fact junk, and only a tiny fraction of them are from people we know, our friends, colleagues. So to save us time on reading junk email, spam filtering algorithm can try to filter the bot generated spams from real world email. The next area that are using data science is automatic language translation, where, for example, Google Translate will translate a sentence from French to English or Hindi or any other language. And over the years, that translation ability has grown as the algorithm has got better. Before, it was doing a lot of literal translation, but nowadays, if you look at the output, it gets more context, it can understand more figurative expressions as well. Another very different area where data science is being used is farming, where for example, drones are being used to capture images of orchards, of plants, of fruit plants, and then you would use those images to identify which fruits are ripe and ready to be harvested, and then farmers can optimize their harvesting efficiency based on the recommendation of the whole system. We have self-driving cars from companies like Tesla nowadays that can try to navigate on roads which are very complex because the landscape around roads are constantly changing. People on the streets, dogs on the streets, and other like signs of speed limits and all of that. Yet more and more we find that self-driving cars are becoming so good that they can more or less navigate by themselves, even though we are not at the point where they're fully foolproof, but they are getting there slowly. In insurance, especially medical insurance, data science is used a lot to try to segment populations based on their um, preponderance of getting some diseases or some like lifelong issues like heart issues or diabetes, so that then you can push those people to be more active in their lives, to make sure that they don't get a condition like diabetes early on, so that their whole premium doesn't have to be too expensive for them as well. Um, Another area is Google Ads, for example, where Google will use your entire search history to build a profile of you and then tailor what ads is relevant to you, because it knows you, for example, say you're interested in computers, so it will target an ad around computers to you. Another very important place where data science algorithms are being used is sales forecasting. It's very important for businesses to be able to forecast their sales, because it gives them confidence of where their business is going, and that's a very complicated thing sometimes to do. In our case, at the company I'm working on currently, we've tried to focus daily on the demand of our drivers, because we need to be sure that if we are going to put drivers on the street to do deliveries, they are going to be busy, so that it doesn't increase our cost. But it's also to increase the efficiency of the system, to reduce our delivery time, so that if there is 50 deliveries coming at one time, we have enough drivers to take care of all of them within 1 hour, for example. Another place where forecasting is being used is inventory. For big companies like Amazon, they don't want to buy too many products in advance, so that they don't have to stock all of that and wait for it to slowly leave their whole warehouses. So forecasting how much demand they will have on a certain product is quite essential, so that they can maximize the storage space that they have. As important is probably for supermarkets which have fruits and vegetables which are perishable on the shelf, and knowing how much demand there is going to be on certain products that are perishable is quite essential for supermarkets, because else if you put 1 ton of product on the shelf and only half of that is being consumed by consumers, the rest you'll have to throw away, and it will become very expensive to you. So those kinds of inventory forecasting is quite essential currently. Another area is customer sentiment analysis, where people will look on social media around trending words or trending hashtags to understand what's the sentiment of people online around a certain product, a certain movement. In banking, they use data science to try to track fraudulent activities on credit cards or internet banking, to avoid their customer from having the very bad experience of losing their money. So it's also another area where data science is being used. Lastly, I would touch on manufacturing, where in big foundries or in big car manufacturing places, factories, you need data science to optimize your process, to make sure that there is less waste going out of the factories, less metal waste, less scrap of whatever primary resources you're using, so that your system is more efficient and more cost effective. So all of those are areas where data science are being used. If we go back a little bit, I would like to show the differences between data science in academia and industry, because there's quite a big gap between the two. And when you surf online, when you go on blog posts, when you go on papers especially, it's mostly data scientists from academia. And the way that they formulate a problem is quite different to how industry works. So in academia, data science is around usually building a better model, a better algorithm that would give high accuracy. If you have an image recognition system, you try to beat the latest algorithm. if their accuracy was 95%. Now, in the next paper, if you get 95.5%, it's good enough to get a paper. In industry, accuracy is not that essential. The model building is part of the system, but not the essential part of the system. It is around the whole system itself. But mostly, data set that we collect in academia usually are very good quality data set. For example, I was in astronomy, and the data set that we collected on telescopes were very good, the best signal to noise that you can have, the best quality of image that you can get, all of that just to get the best science possible out of those images. In industry, you're faced with a different picture because your customer can change behavior. Your customer, you cannot have a few metrics to characterize a customer. So the data set that you collect is usually very noisy and very inaccurate and not ideal at all. So the model that you try to use to model the customer is never going to be perfect. It's very far from it, in fact. It's very noisy. So the model part is less essential in industry. Also in industry, the culture around data science, or even anywhere inside any business, is around what value do you bring to the company. For example, if you are a specialist at developing trading bots and you move to a company which is developing natural language processing algorithm, do you bring value to that company? That's the question that you'll have to answer to the company to be able to be hired, because you might be skilled as a data scientist, but not in that domain. And companies work around what they are operating, and they need people to bring value to around that. Also, another important aspect is how you fit inside a team. In academia, you can do research on your own sometimes, while in industry, you're always working with people around you, so you have to be a good team player. I've had a colleague in the past at the consulting company that I was working in, who was very good data scientist, who was probably the best data scientist that we had, but who was a horrible person. So eventually, the company had no option but to fire him, because his behavior around everyone was horrible, and it impacted on the performance of everyone around in the company. If we look at the next slide, where I've tabulated those differences, I want to stress a few things. First, in academia, usually data sets are quite static, while in industry, data sets are changing because behaviors of people are changing usually. For example, in our case, our drivers change their behavior based on weather. If it's raining, they might have a different behavior than when it's sunny. There might be strikes on some days, and their behavior are totally different then. So it's constantly evolving, and how you adapt to that is more essential than anything else. Metric around accuracy is essential in academia for new published papers, while in business is not as essential. More essential is to understand your data, and then also to build minimum viable product that can quickly go to deployment, so that then you can slowly iterate to get better and better on your model accuracy. The model accuracy is secondary to the whole system. Thirdly, I would say computing is very different between academia and industry. In academia, you can, with whatever computing power that you have, you'll train your model, and then you'll infer your predictions on your model and calculate your accuracy on that. In industry, the computing power is critical to understand, because depending on the solution you're building, the computing power will have to scale with that. For example, if you're Netflix and you have hundreds of millions of customers, if you try to do your recommendation engine live for every customer, you'll quickly run into bottlenecks. So what for example, Netflix does is it batches the data it has collected through a day or through a few hours, and then it processes that, create recommendations for each customer based on that data that it has in its history, and then saves all of that in a database. So when you connect to Netflix, it will then just go to the database and look for the recommendations it has for you and send them to you. But that's a place where batch processing can be used. In other areas where you need to access a model live, then that needs to be built live and needs to be accessed live, and that will usually means it's more costly as well in terms of computational power. But also remember that the more complex your model, the more time it will take to run, the more amount of money it will be required to pay for cloud infrastructures like AWS, Azure, or GCP. So all of those are taken into account when you're building a model in industry. In academia, interpreting a model is important, but is not critical, because as long as your model is working, is improving, understanding the different things happening inside the model is secondary in academia. In industry, in certain industry, I would say it's crucial because, for example, it might have legal ramification if your recommendation or whatever you're calculating is doing something wrong. I'll give an example. If you're a bank and you're trying to give loans to customers and you're using an algorithm to calculate if a customer will be able to repay your loan or not, there might be a lot of legal ramification if you compute that someone is not credit worthy. If that person is someone who is of a specific race and your algorithm is discriminating against a race or a religion or a gender, that whole algorithm that you have built might lead you to be bankrupt because of lawsuits. So to avoid that, you have to be able to develop interpretable system that you can understand of why it has chosen that someone is credit worthy and someone is not, and build something based on features that is not discriminatory. So all of that is something very important in industry. Lastly, I would say that data security is crucial for businesses as opposed to academia. Why? Because businesses have databases of people live in the system. If personal information of people get exposed live on the server or on the website of a company, it will be damaging beyond repair. It could lead to the company closing because of legal actions. So developing secure systems in industry is essential, so that whatever data that you are feeding to your algorithm is always in a secure way, accessed through security levels, and never compromise online in any way possible in your system. Now, let's have a look at the life cycle of a machine learning project inside a company and how to make the most out of it. So the first phase, which is a critical phase, is to scope the project right, which is to define the project, to define what type of data you'll need for the project, to understand the business value of the project, because you can make the best project ever, build the best algorithm ever. If it's not adding value to the company, then it's worthless. So you need to either, say for example, you want to increase customer satisfaction, then you need to look at the parameters around what you will be doing to drive that. So you need to define the project, and for that you usually use business analysts or even some data scientists. It's usually mostly the skill of understanding what's valuable to the business that is at stake here. And after you've scoped the project, and you've rightly scoped the project with all the specification that it needs to be successful, then you start looking at the data side of the project. Do you already have data set or databases inside the company that could help address the problem? Do you need to buy data from another company to address the problem? Do you need to start collecting from your user base data to start improving things for the customer base? So all of that is what you then start looking at in the data phase. And then once you start having a baseline data set, then you can start putting baseline results that you need down the line for the project to be successful. Once that is done, then you'll start having more and more data set that you start having to label and make sure that it is organized in a proper way so that moving forward, the data is accessible, the data is properly labeled, and you can train an algorithm on that. The next step is then the modeling phase. The modeling phase is where you start building your machine learning algorithm, and you start testing the algorithm, like different types of algorithm, and see what are their performances. So that's the usual place where most people understand what's happening inside a machine learning problem in a company. So everyone is familiar with that because they've been on Kaggle, they've done hackathon and all of that. The next step is to perform error analysis and see what are the results, are they in line with the baseline that you've established, what are the artifacts in the data, if things have gone wrong, what in the data through the results of, through the model of, from the expected value that you wanted. So all of that comes from the modeling phase, and it's critical to run good error analysis to make sure that you optimize whatever model you have with the data that you have and get the best results out of it. The last step is the deployment. And deployment is to make that entire workflow go live in the cloud usually. And to deploy in production requires a lot of different things. First, you need to have codes that are properly tested. That's where you throw all the Jupyter Notebook in trash and you start writing like deployment ready code that can be testable, that are properly documented, because if something is going to live in the cloud, people are going to have to maintain that and to monitor it. And if they are going to have to maintain that, then it needs to be properly documented, where it's going to fail, where it's going to run fine, what tests to run in what conditions. So that part is the computer science part, where you need to have all the skills to write proper deployment grade code, business code, like maintainable code that will make the project live for years to come. And anyone new to the company who will join the company can then access the code base and make use of the entire ecosystem that has been developed without too much hassle. For a deployment to be successful, there is a few requirements that I want to discuss that would make it very successful. First, you have to start thinking about scalability. Sometimes a simple logistic regression is better than a neural network, even though if the neural network is doing a better job, is more fancy, it makes you look more trendy. Most of the time, you don't need neural networks unless you're doing computer vision problems. The advantage of simple algorithm is that they are fast, they are resource efficient, so you don't need too much computing power to run them in the cloud, and they are much easier to debug, and they are more transparent as well of what they are doing. So, and that makes them very scalable. So if your user base grows from 10,000 people on your website within 1 week to 1 million people on your website, how do you handle that? You need to have designed a scalable solution that quickly transition from a small number of users to a big number of users quickly. And sometimes that can be happening within a day. Like during the day, people are active and working, so they might be accessing some websites a lot, and at night when they're sleeping, nothing is happening. So scalable solution needs to take care of the traffic and how busy things can get. The next part is reliability. How do you build a model that is reliable and is outputting the right results? Because in a lot of cases in business, you don't know what's the ground truth. For example, in Netflix recommendation, you never know if a user who has not clicked on a recommendation did not like a recommendation or just didn't have time on that day to watch the movie that you've recommended. So what is the ground truth? Is it a good recommendation or a bad recommendation? And how do you evaluate that? In a lot of cases, you don't have ground truth, unlike in academia or in Kaggle competitions. So you have to make sure that whatever you're deploying is reliable still without having access to ground truth or any other parameters. Another important aspect is adaptability, because data changes over time. It's called data drift. What happens is usually your customer base is changing over time, so how people behave at specific moment in the year might be different, or your demographic itself has changed. You might have targeted young people with your product, but slowly more middle-aged or old people are using your product. So because the demographic is different, their behavior is different. So your whatever machine learning solution that you have built needs to be able to adapt to that, or you at least need to be able to retrain your model so that it adapts to the new customer base. Lastly, a very, very important topic is what I've mentioned is maintainability. Any code that lives for a company that lives live and is doing any computation live needs to be maintainable. It needs to be written with the best practices. It needs to follow good documentation practices. It needs to be testable. It needs to have version control on it. But because machine learning system is not only code-based, but it has it has a data component to it. The data that you have trained your model needs to be versioned as well. And that's another important part of keeping track of the model that you're building. You need to version your code and your data as well, so that everything then is reproducible. To sum up the talk, I would like to just give a brief list of skills that a good data scientist in industry needs to have. So the first thing that you need to have is a good understanding of the entire life cycle of data science project when you're in industry. The second part is to understand Git and version control. That's something essential for any data scientist who works at a company. You need to know how to write good maintainable code. That's more important than knowing machine learning itself. There are data scientists that I've met that don't know machine learning too much. They know statistics, they have other skills. But the main skills that they have is unit testing, writing good code, understanding how to write software with good quality. The next skill that is more essential is to understand SQL, because SQL, all companies have databases, and interacting with the databases require good SQL skills. Then after that, the next skill is to understand Python, pandas, statistics, data visualization, and then you need to know machine learning, deep learning, and lastly, then you need to know deployment and cloud infrastructure. So that's how you should go about increasing your skill to be valuable to a company. Lastly, I want to stress that no one can be proficient in all of the skills that I've listed above. That's why good companies don't hire only a single data scientist to do everything in their entire life cycle. Usually you have data analyst, you have data scientist, and data engineer. Data analysts usually do dashboards, work with Power BI, Tableau. They are more in contact with the day-to-day running of the business. They understand what's happening, what issues the business is facing on a day-to-day basis, and they are more skilled at scoping projects that are valuable to the company. Data scientists also needs to be in contact with data analysts most of the time to understand that business side. But then they will be writing code in Python, in Pandas, doing statistical analysis mostly, and data visualization and all of that. Data engineer are mostly the people who will have more skills in the infrastructure and will be mostly skilled in cloud infrastructure, will be skilled in deployment and all of that which comes with that. That is writing maintainable code, making sure everything is tested before being deployed. So all three have their place to be inside an organization, and all three of those jobs are valuable, and all three live within that whole space of data science. With that, I hope you've enjoyed the talk and it has been valuable to you. And next is to answer your questions if you have any.